a flash of lightning and a rumble of thunder. But what exactly are these spectacular occurrences? In 1752, Benjamin Franklin discovered that lightning was caused by powerful electrical discharges in clouds. He wasn't the first person to discover electricity, or the first to think that lightning was made of it. But he did prove it to be the case by flying a kite during a thunderstorm. Luckily, his kite wasn't actually struck by lightning, because it would have fried him in his boots. Thunderstorms are caused by small electrically charged particles. As water molecules in the cloud are heated and cooled, they move up and down against each other. There is a separation of charge, forming two poles within the cloud. One part becomes negatively charged, and the other part becomes positively charged. Objects on the ground then become oppositely charged to the lower part of the cloud. This imbalance tries to resolve itself by passing current between the differently charged poles. Charged particles always flow in the direction where there are less particles of the same charge. This results in a lightning bolt. Sometimes the bolt will carry a positive charge and sometimes a negative charge. At first, there is a bolt which is invisible to our eyes. When the invisible lightning bolt gets close enough to the ground, there is a powerful discharge of energy. So powerful, in fact, that it results in an electrical arc. And this is the lightning bolt that we see. The electrical arc of the lightning bolt heats the surrounding air to extreme temperatures. In fact, the air around can be heated to 5 times hotter than the sun. This heat causes the surrounding air to rapidly expand and vibrate, which is the rumbling thunder that we hear. So lightning can come in many different colours, and the colour depends on atmospheric humidity, temperature, and levels of air pollution. Lightning also transports massive amounts of energy, 5 times hotter than the sun, so that makes sense. Each bolt carries about 10 billion watts. That's enough power for 32 million people a year. 10 billion watts per bolt, and given that 50 bolts strike the Earth's surface every single second, means the power of lightning is extraordinary and dangerous. Over 2,000 people a year are killed by lightning. So extracting electricity from lightning sounds like a good idea, right? Well, in reality, predicting where the lightning is going to hit to have our equipment is nearly impossible. We'd need to develop technology that can conduct and store this amount of instantaneous power. The equipment has been predicted to cost over $90 trillion US, which is actually all the money in the world. And we don't know if the lightning bolt is going to be positively or negatively charged, and so our equipment would need to cover both possibilities. However, scientists are still trying to see if they can harness lightning electricity. Why not? You might as well try. So, we've seen that lightning is an electrical discharge caused by imbalance between storm clouds and the ground. Thunder is then the heating and vibrations of the surrounding air particles. Given how powerful and common lightning is, our cars, houses and aeroplanes are protected from lightning. The metal frames and rubber tyres of cars harmlessly carry the charge to the ground, and houses and buildings have conducting rods to do the same. And lightning bolts travel across the aeroplane's metal shell and leaves without the passengers barely noticing it's happened. If you liked the video, give it a thumbs up, and don't forget to subscribe. Comment below if you have any questions. Why not check out our FuseSchool app as well? Until next time.